All right, hello. Welcome back to another episode of the podcast. I've definitely lost count of the episode count, so um, let's just call this episode the Chat GPT episode. Okay,
We're
because
just
that
now.
yes, we'll figure it out if it ever gets uploaded. Hopefully, everything's recorded right. Unfortunately, we did make an episode a couple months ago, but we had some technical difficulties, aka I did not set up the stream properly and my mic was not being recorded. So that episode will stay in the vault. Maybe one day we'll re-record it and release the final version because that was a really good conversation. But regardless, we're back and we're gonna talk about a topic that's been getting more traction recently, which is some breakthroughs in I think AI specifically what OpenAI has come out in the form of a chatbot called GPT-3. But before we jump into that, Tony, my co-host, how are you? How have you been doing?
I'm good, man. It's a bummer that the last episode didn't work, but who knows? Maybe one day AI will get so good we can just run it, do some
Maybe,
reading,
yeah. Now that would be next level. Yes, once AI can process videos and images, maybe yeah, we can lip read and render the text and the voice based on my existing voice patterns. That would be really cool. Yeah, actually, as an aside, I don't know if you saw there was these. I saw these glasses apparently these AR glasses that are for deaf people, and it's supposed to be able to lip read and generate captions for them like live. Which
Mm.
yeah, kind of seems like what we're talking about. So yeah, definitely a lot of cool examples of AI breakthroughs in the future. But again, for today, we just want to stick on what OpenAI has been doing with their chat AI, ChatGPT 3. Specifically, we want to talk about what it can do, a bit of how it works, and some of the limitations that it and all forms of AI currently face today. Tony, you have some experience, not professionally, but as an AI enthusiast, I would say, over the years, right? Where you have definitely read up and even done some personal projects related to AI machine learning, right? So, I guess before we jump into it, what are your thoughts? Just what was your first reaction when you saw what OpenAI released and when you saw ChatGPT? You got a chance to play with it. What were your immediate thoughts to this?
Yeah, I mean, when I first heard about it, my initial reaction was honestly like, oh, another one.
Yeah.
Another large language model using transformers, right? Like it's gonna be hyper realistic, but it's probably gonna have the same issues as its predecessors had. Then when I played around with it, I was like impressed by what it was able to do.
Yeah.
Uh, but as I kind of delve into it a little bit more and thinking about it, using my past experience and past knowledge and stuff, and fitting into, I guess, my existing framework for thinking about these things, I think it came back to the same thing. It's like another one.
Okay, that's awesome. We're gonna come back to that. We'll relate it back to previous models and what it does differently that made you think this is cool, but also what made you ultimately realize that it hasn't made what you believe to be a true breakthrough in AI that can lead to the next steps of actual real AGI, so to speak, right? Before we jump into that, just want to quickly talk about what ChatGPT is, right? So for people who don't go on the internet much, OpenAI recently released, I suppose, a new version of their GPT model, and they have encapsulated a chatbot that you can use to interact and have conversational dialogues with this model. So, one cool thing that it does, among many, is that it remembers the context of your previous conversation, and you can add on to it almost like you would talk to a human, right? And it's able to remember and process that information regardless of how long ago you spoke to it about. And yeah, based on that, it's able to spit out more accurate information or outputs because it has the prior context of your previous conversation. So, really quick before we start the pod, I did some quick prep on trying to explain what ChatGPT is to the layman, to people who are not in the technical field and wouldn't really know how AI works underneath the hood. And I thought the best way to do this was to ask ChatGPT itself what it is, kind of an existential question for our little chat AI. But let me bring up the results real quick. So here, I on the screen right now, I just have the ChatGPT website, and I asked it explain how ChatGPT works in terms that a high schooler would understand, right? And I'll just quickly summarize it for the listeners who are not watching. So ChatGPT 3, it says, is a chatbot that uses a large pre-trained language model called GPT-3 to generate responses to user input in a conversational manner. Right? The chatbot is trained on a large amount of text data, which it uses to understand the context of a conversation and generate appropriate responses. So, like I said, it flows like human conversation. There's been examples you can see of people mimicking real life conversations with it, and it seems very convincing. Like it to me, at a glance, it seems like it could maybe pass the Turing test, right? Based on what it's spitting out from those snapshots. And so it goes into further detail. It says when you talk to ChatGPT-3, it uses GPT-3, the large model that it's been trained, to process your input and generate a response that is coherent and relevant to the conversation. So, for example, if you ask it a question, it will use the model to generate a response to provide an answer. And you'll notice right away that it's kind of regurgitating some information over and over. And this is partly because I would assume that I told it to explain in layman terms, and it's trying to emphasize like the core of what it does, which is conversational input output with this AI chatbot, right? And so it summarizes by saying overall, it's a way for talk to a computer in a more natural and conversational way, using the power of AI to understand our input to generate appropriate responses, right? Before we go further, I think this is a broad-based explanation of what it can do. It doesn't really cover really the cool things that people have been using it to achieve, right? If you just read this snippet, you would assume that it's one of those, like you said, just on the chatbot, and a bunch of those exist already. These days, when you go to customer support, half of them are chatbots, right? They're just kind of very rudimentary ones with a lot of like certain pre-selected options that you can choose that are mapped to pre-selected responses, right? What makes this one so cool, I think, is the large amount of data that's been trained on. And so it can do a lot of cool things. Like people have been using it to generate, running code that works with minimal changes. People are able to use it to debug their code, right? People can use it to pretty much write any college level essay that's certainly passable within a minute. It's really good at spitting out the information that is, I think, commonly searchable on, for example, Google Stack Overflow, right? A lot of like the text that is on the internet, I think it's become very good. It's parsed through that, and it's become very good at knowing when you're asking it questions for those topics and drawing out coherent responses, right? Tony, do you think that actually kind of captures what it does to, I guess, the average layman, to a non-technical person, right?
Yeah, I think first we have to be careful with anthropomorphizing it. So you said a lot about like, you know, it's like remembering things or it's like understanding things and that sort of thing. I don't think we can ascribe any of those qualities to it. At the end of the day, essentially, right? Like you mentioned, it had this huge amounts of training data. Essentially did it did a statistical regression. You can think of it that way, right? On all that data. And then now it's able to come up with really cool outputs because that model is ginormous, right? It's
Right.
like a 100 trillion parameter model. Um, but as an overview, I think that's correct, is that it's read all this information, it's synthesized it. I don't think we can say it understands it, but now it's very good at using that to create outputs given new inputs.
Right, right. It's kind of like if you were to give a human toddler a vast amount of, I don't know, visual information. Like if you were to just show it hours and hours of TikTok dances, right? The toddler would grow up thinking that that's normal behavior, and right. There's like it's kind of to I guess to use do you know of the allegory of the cave, right? Like Plato's
Yeah.
cave. Yeah, so it's like it depending on the information we give it, that's what it believes is the truth, and so I shouldn't say believes, but it will mimic that because that's all it knows, right? And in this case, this model has just way more information and parameters than maybe any other model that's commercially or like widely available. I believe, publicly available at least. To my understanding, yeah, because it has so much information, it's passing off as almost human-like intelligence at a glance because of the way it's able to craft its responses so elegantly and sometimes so accurately because of the vast amount of information it's drawing from. But you want to make that distinction that it is not necessarily understanding what we're doing better than any previous model. It just has so much more mapping ability to give you a more relevant answer. Would that be correct?
Right. It's just a really good model, right? Think about, let's say we're trying to model, I don't know, the stock market, and we use a linear regression. We use LF plus B, right? Like we have one fucking straight line, right? And that's not going to be very accurate, right? But then
I
if we
mean,
add more,
for my portfolio, it's pretty accurate. It's one straight line all the way down.
yeah,
Yeah.
we have y equals negative x.
Yeah. Sounds about right. Yeah. Yeah.
Yeah. But then if you add more parameters to it, right? If you do an x squared, now you can have a curve, right? If you do x
Yep.
cubed, now you can have an s curve, right? Now it
Right.
has two inflection points, right?
Yeah.
X to the power four is three inflection points, right? More parameters that you add, the more accurately it can do the mapping, right?
Right.
And so that's what they've done. But rather than four parameters, they've done like 100 trillion parameters, right?
Right.
And so the result can be quite amazing.
Quite
Um,
detailed and quite specific in some cases.
Exactly. But even if we had a really great regression of the stock market that can predict it really well, we cannot say that that model understands what's going on, right? So similarly, we cannot really ascribe any understanding to this model because it is in essence a large regression, right? Um, I think to just explain kind of like this stuff in a little bit more detail, I think we can talk like maybe briefly about like the history of neural networks and stuff. Um, so
Yeah.
the simplest is kind of what I already outlined, a linear regression, right? I guess it's going to go into a little bit technical detail. I'll try to keep this part short. But if you think about how a neuron works, right, it's taking in inputs from all the nearby neurons, right? It's summing it up. It does a summation in the body of the neuron, and then it either activates or it doesn't activate. So it passes through this like activation function. That's all or nothing, and it gives an output. So something that mimics this, right, would be a artificial neuron that takes in all the inputs from its neighbors, adds them up, then again does some kind of a non-linear transformation, does the activation function. In this case, a lot of times instead of doing a step function, either 0 or 1, we transform it to a result between 0 or 1. So
Right.
we get a sigmoid
You're adding
function.
more granularity to the final result because
Right.
yeah.
Also, it makes it differentiable. That's the biggest, is because a step function is not differentiable because it's not a continuous function, right? And this factors into the training. But what I just talked about is actually kind of how logistic regression works, right? So there's kind of like one layer of neurons. Then you can add more layers of neurons, right? And when you get add more and more layers, that's why we call it deep learning. It's
Right.
deep in that the network is deep. It's got many layers.
We're
And
yeah,
yeah,
sorry. Before you continue, we're throwing a lot of I think technical terms out there relevant to the AI machine learning field. Let's try to contextualize all of this. Like, there's been a progression of AI advancements over the years, right? And we started with something as simple as linear regression, and eventually we add more and more parameters. We add more and more complicated learning mechanisms, right? So let's kind of give a general outline of the beginning to now and where GPT-3 fits into that timeline. Would that be okay?
yeah, sure. Yeah, so um, basically, right, neural networks weren't really used for a really long time just because they were really hard to train, especially the ones with many middle layers,
Yeah.
right? Such that they become deep. Just mathematically, no one really had a good way of training them. So they were mostly like not used for a long time. I think it wasn't until like the early 2000s, I want to say, or the late like 90s, when people came out with a way to easily train these things. And then it just exploded in popularity because it was so accurate. Because now you have this model that has so many parameters. So just like what we mentioned before, the more parameters, the more accurately, the more fine-grained details can exist in what modeling, right? So like we said, like a simple linear regression is one straight line. If you add another parameter to it, right, then now it can do a curve.
Yeah.
If you do another parameter to it, now it can turn that curve once again. So instead of like a
Yep.
U, it's now an S, right?
Have you
So
seen
you,
those like graph arts before? Like, I remember in high
yeah,
school, someone was like, "Oh, look, there's the Batman function," and it's like literally the Batman symbol in it. Yeah, with enough extra parameters and yeah, you can create some very detailed charts, and you can fit that into more complicated models and stuff, right?
right, absolutely. And then there was like kind of specific types of neural networks used for specific things. So like convolutional neural networks became a big thing for image recognition.
Right.
And that's because in many ways, they're very similar to how our own visual cortex in the brain works. So the type of like the layering, the convolutions. I remember learning about like spindle cells, I want to say. There's kind of like a biological similarity to how the brain works. And when you train them, they actually start performing like somewhat like how the brain works with images,
Right.
right? And that gave you a lot of power to image recognition. And then the thing was, well, these things are just, like flat images, right? What if I want to do a video or audio, like a sequence of data? And then they came out with this thing called recurrent neural networks, which is another type of neural network architecture that basically has connections to itself. So at every iteration, right? Let's say you say the sentence, the river of the bank. That's not a sentence, but or the bank of the river,
Bank of the river. Yeah.
right? It would feed the word the in, then bank in, of the river, right? And then and every time it's able to is able to reference itself, and so it can learn associations even within that sentence. But the further away the words are to themselves to each other in that sentence, the less powerful that association is, right? Even though, right, like if write a paragraph, a word in the very first sentence might be related to a word in the very last sentence, right? It's not
Yeah.
that there becomes less and less related over that paragraph.
Yeah. Yeah.
And so transformers, which is a technology that GPT-3 and ChatGPT use, came out in order to kind of like solve that problem. The attention mechanism. I think that's kind of a broad overview. Um,
So, would you
and
say that the breakthrough that GPT-3 model has is not just more training data, more parameters, but also transformers giving it the ability to remember previous context from conversations? Or would you say that was already kind of in use?
yeah, I think that was already kind of in use. So like transformers as a kind of like a model architecture were in use. I'm pretty sure before GPT-3.
Right.
But um, yeah, but the thing with these models, right? Like you asked it like what it is, and it said I'm a large language model, right? Keyword large. These are very large models that are very expensive to train, requires lots of data.
Right. Right.
That's what makes it so powerful. Um, and to kind of explain another idea, I guess, in machine learning is this idea of overfitting.
Yeah.
So, for example, let's say my training data had like four observations, right? Let's say height. We're learning the association between height and weight of different people, right?
Yeah.
We happened to, like get four different people, but let's say they all have dwarfism, right? They're all very small, right? Then what we learn is going to be not generalizable, right? And so there's this problem of generalizing to the population. And so one problem with creating these very large models, large parameters, right, is that you fit that training data very specifically, very, very well. It's able to get all those little turns and curves in the graph in, right?
Yeah.
And when you apply it to the general population, maybe you learn too much. Maybe you learn very specific things about just your training data. That's not generalizable. That's always a downside to these large parameters. And I think one of the cool things about the GPT series was that they realized, hey, you can just keep adding parameters and it won't overfit. Like the performance doesn't suffer. And I
Right.
think that's a function of just having so much training data that
Yeah.
there's training data that even if your parameter size is space is super large, it's not overfitting.
Right. Not every model can become that large because it is exhaustive in time and resources to scale your model like that. You need the accompanying training data. You need the people to annotate and train and validate the results. And you need to be able to iterate and improve it over time, right?
Right, exactly. And I think the point I'm trying to get to is that, right, like that's kind of like the magic ingredient here, I guess,
Yeah.
right? And so I wouldn't
That
say there's a
the ingredient
huge
being data, right?
being data and parameter size, like being a size of the model, right?
Right.
But none of that talks about like the ingenuity of the model, right? And none of it says like, hey, this model is something completely different. Overcome all these limitations about neural networks
And
that we've
that
known.
that's kind of the bone that you have to pick is that at the end of the day we haven't learned anything new about how AI behaves. We haven't come closer to achieving AGI, so to speak, and we're still one or two major breakthroughs away from getting more insight into those areas.
Yeah, it's just like it's not so much that no progress has been made. It's just like it's progress on the margins. It's like tweaking and tinkering of like the existing model architectures.
Right, right.
Nothing spectacularly different. Nothing like paradigm shifting. Nothing that solves, some of these fundamental issues with artificial neural networks.
Right. It's like you have a car and it's really nice, but the base car and the base engine hasn't been changed since I don't know 5 years ago. But you're able to continuously get upgrades on it and you tune it up and you're squeezing as much performance as you can out of it. But it's still the same car and engine from back then.
Or
Nothing different.
or not even the same car and engine, but like, think about the cars that we have today. Think about the cars that we had 20 years ago, right? Do they perform better? Absolutely, right? Has there been a paradigm shift? No, it's still a fucking like, for the most part, bearing electrical cars, right? Still like, a gas run engine, right? An
I
internal
see.
combustion engine,
Yeah,
right?
yeah.
It's not like all of a sudden it's like magnetically, it's like it's not like powered by magnets and like floating, hovering, or whatever, right? It's still four wheels on the ground, right?
And
Got
we're
these
trying to get to the hovering stage.
right. So like what would get us to be able to teleport, for example, like as a method of transport, that would be a paradigm shift, right?
Okay.
That would overcome many of the limitations that we have with cars.
Right. Right.
Mhm.
Yeah, I think that's a good way to contextualize the scale that we're looking at here. And it is really impressive to see what ChatGPT is doing. But if we take a step back, look at the bigger picture, we haven't gained more insight into that final piece of the puzzle, so to speak. And it might not be the final piece, but it's just the next step in shifting the overall paradigm of how AI works and behaves currently.
Right. So, we briefly explained how these artificial neural networks work, right? But essentially, they try to essentially you feed an input and it creates this complicated mathematical mapping
Yeah.
from that input to an output. And once you do that, that's it, right? And during training, you essentially train that mapping, right? That's what training does. So if we think about that versus how humans work, how human brains work, right? It's very different. We are not, just like our brain is not just this one big mapping, right? It's not just we have input through the eyes, it goes through a map, and then out you say something, and that's it, right? The brain can be broken down into many different modules. Maybe some of the module components are these mappings, right?
Yeah.
But by putting them together, right, having that architecture, right, our behavior is drastically different than what these artificial neural networks do, right? And that's why these artificial neural networks aren't humans, right? They aren't really intelligent yet. They aren't artificial general intelligence yet because of that.
I think that is a really good distinction and comparison to make. Let's let's go back to what you said. is really important, I think, and this is kind of the key of future AI advancement potentially, which is data, right? The elusive, the elusive, powerful resource that is ultimately driving and empowering these models behind the scenes, like you said, is the large amount of data that they're trained on, right? So to briefly talk about how GPT was trained, so the GPT-3 model, so here's my understanding of it. Please correct me if I'm wrong, right? What they do is first they train a model to output a list of results, right? And then they use humans to rank those outputs, right? And over time, that model will know which outputs are it should be spitting out, and it's eventually able to rank on its own based on what the humans have trained it to say like are the optimal results, right? And with this training model, it then we use this or they use this to train the actual data set that GPT-3 is trained on, right? And it uses that to tell GPT-3 which outputs are optimal and ranks those. And it does that over and over again millions of times until it's trained on all the data that's being fed. And it might still be a continuous process even now, right? But the point is to achieve this, they relied on some human supervision to input the training data and to rank the results, and then we use that, which is like so that was trained on a very small subset of the overall large data set that it's ultimately GPT-3 is trained on. Is that right?
Yeah, I think that's roughly how it works, just from my reading of the OpenAI blog on it. Basically how it works is that they had, human assistants at one stage to um, kind of rank what the optimal output was that was spitting out,
Yeah.
and then using that data, they were able to train an optimizer, I guess.
Yeah.
And the optimizer then is used to calculate what the optimal output should be at every stage, right? And you no longer need a human trainer because it's trained an AI trainer, and then the AI trainer trains the AI.
Now, would you say that that's a breakthrough technique? Using a smaller subset of data to train an optimizer, which is then used to train the actual data, or is that already being done in practice as well?
No, I don't think that's a breakthrough. I mean, like, there's kind of like, I guess you can even call it data augmentation has been around. So, for example, there are a lot of times where you don't have enough data to train your model,
Yeah.
and then like you can augment your data. And one example of this, for example, would be like, I want to um, train a model on MRI scans, right? What I do is I only have like, let's say 4,000 MRI scans. I feel like I need a lot more than that. What I do, okay, I start adding noise to my images, right? Each noised image now is a new training data,
I
training
see.
point,
So
right?
you're creating new data off of your existing data set.
Right.
Yeah.
And so in some ways it's doing something similar. I mean, I think Tesla Autopilot also does something similar where it kind of like trains the optimizer itself. Um, I don't think this is, yeah, actually like the labeling of data, right? The
Yeah.
labeling of data has been automated to some degree. Like
Yeah,
you can,
that's kind of what I was trying to touch on is like to my knowledge, currently you still need human annotators to validate the data that the model's spitting out to make sure it's accurate and to tell the model whether it's correct or not, right? It sounds like a portion of that has been replaced with automation.
yeah, I mean, it's not new either. I definitely remember hearing about this in the past. And to add on to it, I mean, it's not optimal either.
Yeah, no, you're
Like
right. It's not. It wouldn't be as accurate as a human doing it, but it's less time intensive, right?
exactly, exactly. It's just to save resources, but you're removing ground truth, right? The whole
Yes,
point of
yes.
these hand annotated data was to have ground truth, and you're creating not you're creating soft truth,
Soft truth. Yeah.
that the AI is generating. So it's
Right.
like if your labeling is done by AI, then how can you know if the results are accurate, right?
Yes. Yeah.
It's it's a little bit dangerous, but it seems to have worked a lot of times.
I totally get what you mean there. And let's just expand on this whole data and human relationship that's a necessary part of AI training right now, right? So basically to train any large model that you want to be accurate, you need a lot of accompanying data, right? Data sets with it. Whether it's for self-driving, whether it's for camera filter optimizations, whether it's for chatbots, right? You just need the right type of data set to accompany the types of outputs that you're trying to create, right? And in association, you need humans to gather that data, annotate that data, feed it to the machine, validate the results, and make continuous improvements in a feedback loop, right? This, to my knowledge, has been a core of all AI model training. And you can't really create a relevant model without both those things, right? The manpower and the accompanying data.
Yeah, I mean, for what we would call a subset of machine learning called supervised learning,
Yeah,
right? That kind of like implied even in the word itself, supervised.
supervised. Yeah.
That includes, I think, pretty much almost all neural network models would fall under that category. There's something else called unsupervised learning,
Right.
and that's sort of like the holy grail, I guess, of AI, which is that if you can get the machine to train itself. I think that exist in there are not very good
Not
right
very
now.
good right now. Right. Right. And that's. Would you say that that's the breakthrough that you are hoping to see from one of these companies? Like, you know, instead of a better, more accurate model that relies on supervised training, you're hoping to see something that, like, once we get this up and running, it can like browse the web and learn on its own as a result after that.
I think unsupervised learning definitely would be very awesome. But I think that supervised learning can also create something very awesome, but it would require a completely different type of model. So like what I
Different
mentioned before,
architecture and infrastructure underneath.
yeah, like these models right now, they're just input output mappers,
Yeah.
right? To say that something has intelligence, I think would require much more than that, right? Some kind of autonomy to I guess make judgments, do its own thing. I don't even think I can define all the things. I think it's easier to say what this thing is than to say all the things it's lacking. I think it's easier to say like this is not it. This is not intelligence. I
Yeah.
think like listing out all the things it's missing, right? But I think it's pretty easy to look at this and like if you just keep in mind that this is an input output mapper and compare that to humans, right? Maybe humans are just very complicated input output mappers, right? But it's that complexity matters
We're getting
in this case.
philosophical here. What is free thought? What is thinking? Yeah. Are we all
Right,
just
right.
sheep? Are we all lamb?
I mean, these models at the end of the day, right, we're still inspired by human biology. So
Yes. Yeah.
there's some kernel of truth or some kernel of like similarity between us and it, but there's still vast differences. Um, but yeah, like unsupervised learning, there's I think one of the big AI researchers has been talking about semi-supervised learning at this point,
Okay.
as like maybe the key. I think he was saying that like maybe these should be like fill in the blank AIs. Um,
Now,
yeah.
it is what GPT-3 did with training an optimizer and letting that optimizer train on the rest of the data set. Would not that be considered some form of unsupervised? Because the optimizer itself, it was supervised, but the rest of the training was essentially done without much human, I think, intervention, if I read the paper correctly, or the blog rather.
Right, but it's still using data, right? Or like it's still given a data set to train on,
I see,
right?
I see. Yeah.
I think we'll probably even call that supervised just
I
because of that.
Okay, yeah. So that's a core distinction as part of supervised training because you are feeding the data set that it's learning from, and therefore it is limited to what the humans provided, right, to learn from.
Right. And so we've also talked a little bit about, I guess some conceptual differences between like what this AI does and what, ideal artificial general intelligence would do.
Yeah.
But even if we look at what it can do, just look at some of the examples and think about like how it can be applied, I think that would probably also be illustrative of the limitations of ChatGPT. So one of the big things that's been talked about, right, is like, hey, it's going to replace programmers.
Yeah, it's gonna take our jobs.
Right, right. But one thing it's missing is sort of like specificity, right? I was mentioning to you this before, but if you feed it a math question, it can give you a very convincing answer that's just absolutely wrong.
Yeah, yeah.
Um,
But the problem is, it can sound very convincing with that. What's that? There's like a subreddit, confidently incorrect. I think that would be a good way to say, like, regardless of how accurate or inaccurate the answer is, it's always going to sound very convincing and believable, and probably give you a very detail oriented answer if you ask for a technical question. And I think that's
right.
one of the pitfalls, is it's much harder to validate whether that's right or wrong if you're not really thinking for yourself and relying on it to give you output.
Yeah, and I think this point is actually kind of illustrative of um, the difference between that and like human intelligence is that with humans, right? Like, so what it's doing, right? It's just kind of like looking for the best looking answer, I guess, in a
Hmm.
way. It's like it's mapping the input to the output, right? So like it's seen numbers before, right? And it's maybe calculate some like fuzzy relationships between numbers and like operations and stuff, and it's like seeing the answers, but it's not able to understand exactly what it's doing. It's not actually multiplying 15 by 15 by 15. Like, so I asked it the question 200 times 15 to the power of 3. I think it
Yeah.
gave me like 4 million something as the answer. The real answer is like 6 million something, right?
Hmm.
It looked very convincing. It even showed me its work. It was like 15 times 3, if time 15 times 15 times 15 is this, and then you multiply 200 is this. And it's just absolutely wrong. And the reason is because it's not in its head, like, when we do math, right? There's these rules that we follow.
Yeah. Yeah.
So that's one of the key differences between this new generation of AI versus old AI. Is that AI, when people originally were like trying to create AI, they were building it by just putting in tons of rules. Kind of like how our programs look today, right? Like
Yeah.
you look at your code base, how many if statements are there, right?
Oh yeah.
Tons, right?
Hmm.
Turner, right? Um, that's how we program, right? Because
Yeah.
it's very straightforward and
Yeah.
it's consistent. It's going to give you the same result every time,
Consistency. Yes. Yeah.
right? And accuracy, right? By doing that, you are going to be very accurate. It's going to be the same thing every time. Um, and that's what we tried with AI at first, and it just broke down because like we realized there are way too many fucking rules in the world. Like,
Yeah.
and encapsulate all of them. There is actually a project out there where they did like catalog these rules. I think they're like in the 500,000 rules or something now. Like there's this company that does it.
Interesting. Okay.
Yeah, but for the most part, this strategy was given up on. It had its benefit, as downsides. Another example, for example, like I ask it, is what is a chair, right? And
Hmm.
like we define the rules for a chair. It's like four legs,
Yeah.
has a back, has a seat or whatever, right? Then is a beanbag a chair, right? It violates all those rules. It's just too brittle.
Hmm. Hmm.
And what we found is that using statistical models, like using neural networks, we can be much more robust.
Yeah. Yeah.
Right? It's much less brittle because you're looking at associations at all levels, and it's like kind of all calculated through training, all associations, no explicit rules, right? But what we sacrificed was basically accuracy and specificity when we do that. And that has shown up in all these AI models, right?
Mm.
The old AI models are very good at math, right? These are the calculators, right?
Yeah.
And the new AI models are terrible at math, but they're much better at language, for example, right? Much better at image recognition.
Hmm.
So then that's the question of like, what is the brain doing differently that it's able to do both, right? And that's just one of the examples of like, hey, why this thing is not true intelligence, right? We somehow have the ability because I can look at that question and go like, hey, that looks right. But then I then have the ability to go in and delve into it and like look at the specific operations, do them one by one to know that this is the wrong answer.
Right.
This AI just input, output, bam, that's it. I'm done.
I think that's a great point that you made about the differences between the old AI and the new AI, as well as the technical implementations. There's these hard rules to follow. It seems to me like humans, we're very good at keeping in mind these implicit rules and recalling them on command. Like once we see something, once we observe something, once we go through the motions, we're able to draw from our memory and repeat those actions in the future. And I think like we can remember these 500,000, maybe millions of rules over time, but it's not like it takes up a lot of brain space to recall them. It kind of just happens naturally, right? Like by instinct at a certain point. And I don't know if we can really, I don't know with the current state of AI whether that's easily reproducible. But do you think something as simple as, combining different AI models and putting them under one hood? To my knowledge, ChatGPT actually has some kind of coding shell built into it. I don't know the full details, but you linked me a video. I was able to watch it do a lot of really cool coding things. I think some of that's been patched out, but it sounds like one of the reasons it was able to achieve that is because there's essentially like a terminal built in, and it's able to actually understand or run code. I don't know if that's necessarily true, but do you think the answer to a better form of AI can be as simple as taking the AI with hard rules that was good at raw computations or a number computations, taking it, putting it with conversational AI, and like eventually adding new modules to fit specific needs, such as multimodal input output and whatever use case that we haven't thought of, right? Like, is it as simple as that, or do we need a new paradigm, a new system entirely?
Um, I think you're right in that I've always thought that the breakthrough is it's just as simple as putting modules together. Just like how our brain has different parts
Yeah,
that
because I feel like part of that, what makes our brain so powerful, is like right brain, left brain. Like it does different functions. Is it's not overwhelmed at any given point, right?
right, and it has the separation of functions, but then also vast networks of connection. Now the and but then that's the problem. How do we link up all these different modules? What modules do we need, right? That
Yeah.
architecture is not clear. And that's why most of these models, right, they're single modules essentially, right? They do one thing. They map one thing to one thing,
Yeah.
right? They map text to image, they map text to video, video to text, whatever, text to text, right? Um, but how do we put those things together so that has function? So for example, with our math example, right? Like I was thinking about like how our brain would do it. And to be honest, I'm not sure. But one of the things maybe is that like we have a module in our brain that recursively checks the answer, meaning that we
Mm.
do a first pass, right? Like that looks about right, but I want to make sure. Then it's able to hone in on like different parts of the operation and rerun maybe the same module or maybe a slightly different module, right? And then check that again and again and again until it gets to the right answer. Maybe something like that. But again, like we don't know, right? These are complicated brain circuitry. And so it's been a lot easier to just have like a single mapper module, right? And just train a shit ton of stuff on it. And there are cool behaviors that emerge from that, but there's some behaviors that I think would be hard for it to do. Like, for example, I kind of wonder now if I ask GPT-3, like, hey, your answer was wrong, right? Can you correct it? Would it be able to?
Yeah,
Right?
that's a good point. Okay, when I think about it from this framing that you've given, could it be that part of the reason why humans we're so much better than AI in that regard is because our input sensors are just way better than the AI input. Like we can get input from our eyes, from our senses, right? But not only that, we can reread the input over and over again as much as we want on command, right? And the AI doesn't really have a built-in mechanism to do that, right? It relies on what we feed it at any given time. And like you said, one input, one output, done, right? Until the next input comes. Do you think there could be a way to build in some kind of revalidation of the same input if it feels like the result it spits out is not as high of a score, optimal score as it could be? Do you think it even knows that it could be better, right?
Yeah, right. Really interesting questions. So yeah, maybe there's a module that can calculate confidence, right? Um, it's just I just don't think anyone really fully understands how the brain works,
Right,
right?
right.
That's because we're not able to translate that directly to an AI. But I think that's also partly why the AI advancement has been going this way, is that this is the easiest way to go. Like,
Yeah.
why think about what modules we need? Why think about completely new, different model architectures, right? Like, why having to think about how to piece two modules together, right? let's just make the module bigger.
Right, right. Yeah, I think that's fair, and I think you're right. It's gonna take another breakthrough from a new perspective, a new approach to really get to that next step of what we want to see as true artificial general intelligence, where it can maybe think for itself, it can correct itself, and it can validate its own results. Right.
Right. So like each individual one of these functions, maybe it's a little input to output mapper itself, right? But we could be talking, we may need tens of thousands of these little modules.
Right.
And how do you train these modules? And how do you train them in such a way that they can communicate in a common language, right? That's
Yeah.
going to be the challenge. And also understanding the brain enough to be able to like put that together. Or maybe we don't need to understand the brain. Maybe we can come up with a completely new architecture. But I just haven't really seen a breakthrough in that direction. So far, I mean, like ChatGPT and these transformers, they're just getting bigger and bigger, right?
Yeah.
Um, no one's or like there are people working to create these different architectures and different models and stuff, but they're not being highlighted. And I don't think there's been as much advancement on that front.
Yeah. Yeah.
There's actually like there was a cool book that I read last year, I think, called Thousand Brains Theory. And it's this guy is really interesting. I think he founded he invented the Palm Pilot back in the day.
The Palm
Uh,
Pilot. That's the
it's like a
BlackBerry.
it's like pre-BlackBerry.
Right. Yeah. Okay. Okay. Yeah.
Yeah. Um, but then his real interest is in neuroscience. So when he got rich off the Palm Pilot and stuff, he quit doing that stuff and he went to computational neuroscience and he like funded his own research and stuff.
Cool.
And he thinks that yeah, like AI breakthrough will come down to something that's gonna have to resemble the brain a lot more.
I see. Yeah.
Um, and yeah, like he's got theories on that, some really cool things coming out of there. I think that's a super exciting thing, as opposed to just watching the numbers go up, like 100 trillion parameters, 1 gazillion
How much
parameters.
higher can we go? And
Yeah,
yeah, I think you've broken it down really well about the current state of AI, where GPT-3 fits in there, and what the future of AI could be. I think that's really helpful. Thanks for all that. Let's end the show because we're close to an hour, but I want to end it on a final topic on the potential future of AI, right, and the advancements, and it relates back to what we talked about, which is the importance of data, right, in advancing AI. Seems like as long as we aren't making any crazy breakthroughs in unsupervised learning, data sets are going to be a large piece of the puzzle in advancing the current state of these large neural networks, right? And currently, the data belongs in the hands of a few companies, right? Google, Facebook, Apple, TikTok, right? Really, right now, data is in the hands of companies that have products that the mass consumer uses every day, essentially, right? And there's been some arguments and debates about, I guess, whether these companies should be collecting this data in the first place, right? Like how they're using it, if they're misusing it. Regardless, it's pretty clear that data as a resource itself is valuable and is going to continue being more and more valuable, right? And there's companies right now that offer solutions to provide trained data or just data sets, period, like such as Scale AI to some of these other AI companies. But let's just talk about OpenAI first directly, right? This company, I believe, was started with a mission statement of democratizing AI to the public. It rose as a direct answer to the concerns of data being in the hands of like a few select big tech companies, and they said, hey, like we don't want that. We don't want data. We don't want AI to be only curated by a few select group of people. We want to make it as open as possible. The funny thing is, now that they've had all these breakthroughs, and they've gotten funding and they've able to make their advancements, their models are behind a closed door, right? If we don't really know what's going on underneath the hood, we can only rely on their blog posts for some specs of information. But again, it seems like we've created another Google competitor that hasn't really addressed that issue of open democratizing data, so to speak. But aside from that, I think given the current state of these AI companies and how crucial data is, do you think there's this danger where, AI is going to be curated by these like powerful, a few select powerful companies? They may end up working with the government or whatever, or their own whatever purposes, right? Do you see any dangers and long-term implications of that?
Yeah, I mean, the whole thing is just so thorny. Like around data privacy, just the implications of this technology are super thorny, right?
Right. And let's not
Uh,
forget one of the most common uses of data right now and has been for a while is targeted advertising, right? Which is a really controversial topic and it's kind of split. I think it's very divisive. Like some people are very much in support of it actually because they believe that it allows customers to find business, or sorry, vice versa. It allows businesses to connect with their core customers better, right? And allows people to like find things that they find useful. Whereas untargeted advertising, you can argue, is effectively just spam and a waste of your time and effort to look at, right? And obviously, there's the side of the people, and this is probably the more common popular opinion, which is, my right to privacy, my own data, you should not be exploiting it and making money off that. Just a hard no, right? I've noticed typically the difference in opinion actually comes down to age. It seems to me like younger people have an easier time accepting like, hey, I'm being tracked on these apps, but that's fine because I'm being pushed stuff that I find interesting and I want to find more of. So, I accept that I'm being tracked basically. It seems like a different generation mindset, right? But, potentially the implications are over time there's going to be more and more data out there available to be tracked and to be used and to be monetized or used for other means, right? So I think do you feel like, let me just put it this way, do you feel like there should be regulations in place in how this data is being collected and used? And do you feel like, that, or do you feel like it's fine to be in the hands of like private companies for now?
yeah, I would actually zoom out first. So
Okay.
I would think about this from the perspective of any technology. So it seems like one thing that we're reckoning now with was, in the past, we always thought of technology as just simply a tool, right? It's it's like you're given a gun, right? You can choose to shoot someone or not shoot someone with it, right? That was kind of
Yeah.
like what you have been saying.
Yeah.
I don't want to get political here. I was trying to think of a better example,
No, no,
but
no. That's exactly the example I was thinking of too.
right, right. But actually, there was this guy called Marshall McLuhan. He had this article where he said the medium is the message, and I guess this I'm trying to draw an analogy here, but he was talking about how the digital media is not just like a different medium to show you the same messages that you can show like whatever message you want, right?
Yeah.
But actually the medium shapes the message that you receive. So in other words, that the type of technology you use also shapes how it's being used, right? Which kind of makes sense. It's like certain technology, certain things easier to convey, some things hard to convey, right?
Yeah, that does make sense.
Right. And so what I try to think about with, I guess, with any new technology is how does it, I guess, shape our environment and how is it going to affect us in that way? So think about social media, right? And what's happened, like people are spending more and more time on screens than ever before, right? Which has health implications, right? It seems to trigger mental health issues as well. So like Instagram, I think, has been linked to like young girls like poor self-worth and stuff.
Yeah, yeah.
And just like constantly evaluating yourself, judging yourself. Um, Also think about like what these companies have done, which is like they literally look into like what's how to make the product more and more addicting.
Yeah, yeah.
It-
Sorry, the,
That
the, the, the word you use in the industry is maximizing engagement. We don't want to use the A word,
right,
it's potentially harmful. It could be a microaggression, but engagement sounds, like ooh, growth.
right. Like both hacking and stuff. Like what's wrong with organic growth, right? Where you have
Yeah.
Um, but what I'm trying to get to is that we need to be really careful about how this shapes our world. So one example of AI shaping our world, right? You talked about targeted advertisement, like along the same lines, right? Recommendation engines, right?
Yeah.
The groups that Facebook recommends you, right? It can have this echo chamber effect, right? Where it's like it sees what you like now and it keeps pushing it on you. Essentially, polarizing you in that direction. That's like an unintended consequence of AI that we never
Absolutely.
thought of. We thought of
Yeah.
AI as a tool, right? We would never thought about that, but it has environmental implications in that way. You
Absolutely. Yeah.
set the environment that we live in. Similarly, right? Like you talk about data, like where are these data coming from, right? That can have a huge effect because if the training set, right, is a certain subset of the population,
And you
then
you talked about
AI will
overfitting before, and this is kind of that problem manifesting, right?
say that again.
Oh yeah, you talked about overfitting before as a potential problem when it comes to training the data. Yeah.
It's not generalizing to the entire population, so you may just get a very general, an AI that targets a specific set of the population or that works for a specific set of the population, doesn't work for others. But when I was in medicine, one thing that we're grappling with now is that a lot of the clinical trials in the early days were done pretty much like I think upper middle class white people. And we start to realize that, hey, actually these drugs work differently in other people, right? And actually even like it was like upper middle class men, white men
Right.
for the most. So like we're starting to realize some of these drugs work differently in women. Like
Yeah.
it's an issue that like it's not something that's like immediately appreciated, but we should, given our history of how technology has affected us in like just the past like 20 years, we should probably think very hard, right, about how we are going to implement this technology. And there should be more upfront thought into it and not just what's happening in tech in the last 20 years, right? Which is just like, you know, it's just like a free for all. It's a wild west, right? You can just do whatever you want. Kind of like how crypto is right now, right? But because of all these implications, I think we need to be quite careful.
I think
Yeah, I didn't
that's
really answer your question directly though, right? In terms of like regulation stuff, yes to regulations. Yeah, I don't
No,
know.
I mean, I just thought I should ask a question at the end of it, but I think you were kind of answering my general, like it was more of a thought exercise on how data will be used in the future along with the progress of AI, and I think it's something that like right now everyone is super enthralled by what the AI can do currently, and that's what's eye-catching and attention grabbing, but we should be thinking about the long-term effects of like what this technology will do, and it certainly will have an impact in our society. I think it's inevitable. It's just we have to be careful in seeing how that works. And is OpenAI a worthy curator of this power? Are they a worthy, guardian of this tool? Right? Is the question. And should this tool be in the hands of, I guess, private corporations? Right now, yes, because they're the only ones with resources that can build AIs of this scale, I think. But yeah.
Yeah, I mean, like if we're asking the question should, then we don't have to just say like, that they're allowed to just because they're putting the resources in. If we're
Fair.
saying the word should, it's like maybe they shouldn't.
Maybe they shouldn't. Maybe they shouldn't. Yeah. But can
Yeah.
anyone else right now? No, not in North America. No.
Yeah, it's really, yeah. I mean, at the end of the day, I think these are very, very thorny issues that require a lot of thought. But my general sense is, yeah, we need to be really careful with what we do here. Um, and certainly, I'm curious as to why OpenAI has decided that we're not going to be open.
It all comes back to capital, right? But yeah, I think that would be a good note to end on. I think we did a good job of covering the things that we want to talk about, and yeah, hopefully viewers and listeners enjoyed what we brought to the table in the discussion of OpenAI and the future of AI in general. Tony, do you have anything else you want to add?
Um, no, I think just in summary, right? It's like this is just another improvement on a
Another
known
one, yeah.
model architecture that's out there. It can do some really cool things, but it has some of the same pitfalls as the previous models. One thing I didn't mention here is actually even interpretability, is that we don't understand how it's doing what it's doing.
Yeah, right,
And
right.
that's also really
The
important.
models have grown too complex for us to look underneath after we train it and say like, why is it behaving this way after a certain point, right?
Right. Artificial neural networks in general are considered black boxes. Like it's really hard to understand them. So I think that's just another point. Um, but that's it.
Awesome. Thanks for your time, man. Really great conversation as always, and we'll catch you for the next one.
See ya.
Bye.